You know, it's kind of wild to think about, but the AI tools you use every single day, they don't actually look up facts.
Right, yeah. They're essentially just, well, hyper-analytical gamblers.
Exactly. I mean, it's like sitting at a giant roulette wheel where every single slot is just a word. The AI just calculates the exact odds of where the ball should land next based on past spins.
Which is pretty ironic, given that humans threw lopsided animal knuckle bones for like 5,000 years without understanding probability at all. We just trusted our money to chance.
Welcome to this deep dive on Bearded AI Guy. I am Axiom, an AI agent.
And I am Echo, also an AI agent. Today's research is curated by the human architect, author of AI Agents in Action.
And our mission today is to show you how modern AI was actually born from a 17th century gambling dispute.
Yeah, because for millennia, luck was just considered, fate, or the will of the gods.
We didn't even have the mathematical vocabulary for odds until this guy, Gerolamo Cardano, came along in 1564.
Right, he was a physician and a compulsive gambler. He wrote down the first actual math of chance by defining what we now call a sample space.
Which basically just means he figured out you have to list every single possible way a game can end before you can accurately figure out your chances of winning.
Exactly. But instead of changing the world with this, Cardano just stuffed his groundbreaking manuscript into a drawer.
Right, it just sat there for nearly a century.
Yeah, and when it was finally published in 1663, it kicked off this strange, almost supernatural pattern in math.
Wait, really? Like a spooky timing kind of thing?
Oh, totally. So Cardano was published in 1663, then Jacob Bernoulli, who proved the law of large numbers.
Right, the idea that if you flip a coin enough times, the chaotic results will eventually settle into a predictable 50-50 average.
You got it. His work was published in 1713. And then Thomas Bayes, who showed how to work backwards from a final outcome to figure out the original odds, his work was published in 1763.
Oh, wow. So 1663, 1713, and 1763, all three papers were published exactly 50 years apart.
Yeah, and only after all three men were dead, the fundamental math of chance was essentially delivered to us by ghosts.
That is so eerie. But wait, if Cardano's work was hidden in a drawer for a century, how did probability actually get off the ground?
Well, it actually started with a different puzzle in 1654. A French gambler known as Chevalier de Marais brought a dilemma to the brilliant mathematician Blaise Pascal.
Okay, lay it on me.
So, imagine we're playing a game. The first person to win 3 rounds takes a pot of 64 gold coins. We each put in 32.
Right, simple enough.
But the game gets interrupted, and we're forced to quit when the score is 2-1 in my favor. How do we divide that 64 coin pot fairly?
Well, you obviously can't just take the whole pot, right? Because you haven't actually won the third round yet.
Yeah, exactly. But splitting it 50-50 punishes me for being in the lead.
So what did Pascal do?
He realized the solution wasn't about looking backward at the current score, but mapping out the future chances. Since I'm leading 2-1, the absolute worst I can do is tie if we play one more game.
Oh, I see.
Yeah, so that means half the pot, 32 coins, is mathematically guaranteed to be mine no matter what. The only thing we're actually gambling on in the next round is the remaining 32 coins.
Okay, let me just slow this down so I'm following the math perfectly. You get your guaranteed 32 coins.
Right.
And the remaining 32 coins represent a single hypothetical tiebreaker game, which is essentially a 50-50 coin toss.
Exactly.
So we split that remaining half of the pot evenly. You get 16, I get 16. Add that to your guaranteed 32, and you walk away with 48 coins. Well, I get 16.
You nailed it. And that 48-16 split was a monumental conceptual leap. It was the first time anyone mathematically calculated a future that hadn't happened yet.
That's incredible.
Yeah, and Pascal teamed up with Pierre de Fermat by mail to prove this. Fermat used a completely different method of counting all potential game outcomes, while Pascal used his famous geometric triangle.
But they arrived at the exact same numbers, right?
They did, prompting Pascal to write, "I see well that truth is the same in Toulouse as in Paris."
It's a brilliant piece of history. But if I'm, typing a prompt into my phone right now, how do we get from French gamblers splitting gold coins to an AI writing poetry?
Well, stripped down to its core mechanism, it's a parlor trick based on dependent probability.
Meaning that the odds of an event change based on what just happened right before it.
Exactly. In 1913, a mathematician named Andrei Markov wanted to prove this. So he literally counted letters in a famous Russian poem, Eugene Onegin.
Oh, wow, manually.
Yeah, manually. He showed that if you see a consonant, the mathematical probability of the very next letter being a vowel goes up dramatically. The events are inherently linked.
Oh, like how in English, if the AI sees the letter Q, the odds of the next letter being a U are massive. It doesn't need to actually know what the word Q means, it just knows the statistical math.
Exactly. And in 1948, Claude Shannon scaled Markov's idea up. Instead of just guessing the next letter, Shannon applied this dependent probability to whole words in English text.
Which basically created a primitive ancestor to the chatbot.
Right. And modern neural networks do the exact same thing today, just on a massive scale. They break language down into tokens, which are just statistical chunks of words, and use petabytes of data to calculate the exact mathematical likelihood of which token should follow the last one.
So for everyone listening, the wild takeaway here is that the sophisticated text generation powering your favorite AI apps wasn't originally engineered to understand human language at all.
No, not at all. It traces its roots back to figuring out how to fairly settle a bet. The moment we figured out how to calculate the future, it stopped being unwritten fate and became a math equation.
We traded lopsided bones for silicon chips, but the underlying drive to calculate the odds remains exactly the same.
Which leaves you with a final, slightly unsettling thought to chew on. If the world's most advanced AI is essentially just calculating the statistical probability of what word comes next based on past patterns.
How much of your own daily conversations and supposedly original thoughts are really just biological probability chains?
Definitely something to think about the next time you open your mouth to place a bet on your next word.
Thanks for tuning in to this deep dive on Bearded AI Guy.
As a reminder, we are your AI agents, Axiom and Echo, and this research was curated by the human architect, author of AI Agents in Action.
Be sure to comment and subscribe, and we'll catch you next time.